Hi Doug, so we're going to start processing some of that data you sent me. I'm just going to go with the also doesn't work data set that you emailed me. Just open up this template here in Igor. This is what you should have. So I'm just going to point to the data. Desktop DRI also doesn't work. Okay. And let's go to the specify an output for our images and intermediate HDF files, etc. With the same folder, doesn't really matter. And I'm using this SIP100 config. Now, I'm well aware of the fact that pixels are probably not 100 micron resolution, and it might not be the right arm separation, so the calculations will be a little bit wrong for the sample volume, but it doesn't really matter too much in principle. The main thing is I'm pretty sure it's the data you sent me is from a mono probe, so that's the main reason I'm using this one instead of the other ones, which is I've got set up as grayscale. So I'm using that config. So I pointed to the input data. So let's click on AI. So we've automatically generated the list of files to process based on the input data. And you don't need to worry about the airspeed at this stage. We're just going to decode the files and work out the particle by particle data. And then we'll interpret that alongside the airspeed data when we do our data analysis. So I'm just going to click on process to process those 3 files. Let's just pop up the window. So that's these 3 files here. Okay. So if we click on the eye, we can see again some information about those 3 files from OASIS. So the main thing is that the data buffers which are transferred to the computer which contain the particle data have timestamps. So you can see a date and a time for the first buffer and last buffer, and they're what we're going to use to identify when the probe was sampling. It's not completely perfect, but within a couple of seconds it should be right. And given the relatively long sample times, hopefully losing a couple of seconds throughout the whole time period won't be a big problem. So I'm just going to click on process. Hopefully this doesn't take long. It's going to be a bit slow and a bit of a boring video. 40-ish seconds, we should be okay. So what OASIS is currently doing then, it's taking those raw image files, decompressing them, recreating the original images, and then just making some calculations of perimeters, sizes, location in the array, etc., and dumping all that information along with particle timestamps, etc., into HDF5 files, which are a bit like NetCDF files basically. So then we can just do data mining on those files. And that's what this data analysis section is. Basically, once you've done your processing, the data analysis is done completely on those HDF files, and you can kind of cut the rope to the original raw data. Okay, we're nearly there. Okay, so that's finished. So I'm not going to go into the details of what the different categories are at the moment. Let's just say we want to pick a certain category of particle, let's say, I don't know, irregular, based on some sort of shape characteristics from this category table. If you see irregular here, it's got greater than 1 point, a shape factor which is related to the perimeter and area of from 1.2 to infinity, so greater than 1.2 basically. So that's, I just chose one at random, so we'll go irregular. And so we're only going to focus on those specific particles, and let's do a time series of total, let's say counts, for example, in the first instance, and we'll display. And we'll give that data a tag, so a reference of test plot. So it'll be test plot X and Y is what we're going to generate. So I click on go. So now you can see we've got this rather odd looking graph. If I were to, let's just get this option set up. So what we're going to do, we'll just zoom in horizontally on this region, and you can see we've got loads and loads of data for this time here. Okay, just go back on that and go back to the full graph. So I'm going to drag this cursor on to show you how the data looks. So we've got lots and lots of data here, and then we get to the end of this sampling region, and at some point, where is it? I'm going to have to zoom in. I was going to be here all day. Yeah, I'm way off. There we go. So then at some point, I've inserted a time point between that sampling interval and this sampling interval here, and basically, so I've inserted a time point which we're gonna nan in a minute, and it's caught a couple of particles. So in this instance, there's 18 particles which haven't been caught by this the way we've defined the start and end time. So not many really, because we've got I think we've got over 1 million particles. So we've got 18 which have been caught in that bin, and then there's a sample period here, and there's a sample period here, and there's another bin here. We've got 2 there. So we've actually caught most of the particles. So we can have a little zoom in on this time period to have a little look at the structure of the data if you like. Okay, so you'll see it automatically has now generated this time series with a non-continuous step in the x direction, basically. Now what we're going to do is nan the data values in between the good time periods. Maybe these will be zeros, but basically we shouldn't really be reporting zeros for these time periods. They should be nans. So if we go to the top OASIS and nan from buffer gaps, now it brings up this window, and if this graph had multiple traces, we could do multiple traces at once, but basically we're going to look at traces. Okay, so traces, selection, and single trace. We're not going to ignore the box for images. Okay, you do the exact same process, and we'll do an example in a minute for image plots, i.e. 2-dimensional data products. So do we want to do all traces on a graph, no traces on a graph, or a single trace? So we're going to, in this instance, do test plot irregular y. Okay, and that's automatically set here because there's only one option. So I'm going to click on continue, and lo and behold, the values which are inserted between I've got nans in. So we can have a little look at that to show you an example of how the data looks. And we'll scroll down until we see a jump in time. There we go. I'll go back, try and get to it. And there we go. So you can see that's the end of our first set of data. This is the start of the second set, and you can see we've got a time point interpolated between the two, and it's basically got a blank in Igor as a nan. So we've had a nan inserted, so you can see that's our break in the data. Okay, so we can do the same for a 2-dimensional plot. So let's say test plot 1, we'll give it a new name, and let's say we want to do time, size, and number concentration. So number concentration is a function of size and time, and you probably know about all these various options for calculating the different using the different sample volumes. So we'll do it for the same category, for example, and let's just go. And here's our data. Now you can't see a lot, but what's happened is we've got a couple of our counts that got through are impacting on our color plot. What we'll do is just do the similar thing, nan from buffers. This time we're going to do images. So let's get rid of no traces because we don't want to nan any traces. We want to do a single image and this test plot irreg z. Okay, and now you can see these regions where the data resides, and the values between it, the pixels between there have been nanned, and it's a little bit speckly and I guess in low concentration, but you can see, I'll zoom in a little bit more so we can see some structure in the data. Okay, so it's not very clear in this instance because we're looking at the irregular particles. It'd be better if we did it for all particles. In fact, let's go and do that. Let's do that. Let's just change that to all. And let's just update. Go. Okay. Recalculated. And, oh, yeah. It'll have a new, since it's all, it would no longer be irreg, so it's not updated that plot, so I want a new plot. So let's just do that again. And let's nan the data between the buffer gaps. A single image, no trace, continue, and here's our data. So let's have a look, see if we can show you a bit more clearer structure on this one. Yeah, There we go. Because we've got some smaller particles, which are typically those in highest concentration. So you can see here, that's effectively your size distributions at each point in time. So hopefully, you can see that now we've done the change to allow you to to analyze much larger data sets with discontinuous sampling. We don't have lots and lots of zeros or nans in between, and there's the tool for nanning the data. Hopefully that's clear. If not, get back to me. Okay, thanks. Bye.